Hey guys, in this video we are going to discuss congruence, mainly between triangles, but congruence can be between any polygons or shapes. We're going to talk about mainly triangles today. And so we start out with our definition. The two geometric figures are congruent if they have the same shape and size. And we're talking about the entire figure, not just an angle or a side measure. We're talking about the whole thing, which means this triangle and this triangle are identical to each other, except one of them may be moved somewhere else, like on the coordinate plane, as opposed to where the other one is. It could be flipped, rotated, things like that. But they're basically the same shape and size. They have the same angle measures, and they all have the same side lengths that correspond to each other. And so we have kind of a new statement now. And we say that triangle ABC is congruent to triangle DEF. And so when you write this congruency statement, you do have to make sure that between the two triangles, they match up like they're supposed to. So for instance, AB is congruent to DE because they each have this one little notch right there. And so AB, DE. AC matches up to DF, AC, DF. And BC, EF, BC, EF. So everything does match up sidewise. Angles, angle A would be BAC. So BAC has to match up with EDF, EDF, correct. ACB, ACB has to match up to DFE, DFE, correct. And then ABC is going to match up to DEF, ABC, DEF. So the three angles do match up also. And all of that has to happen if your two triangles are congruent. All right, now there are some ways to be able to tell if two triangles are congruent. And one of them is called the SAS congruence, which means that two sides and the included angle of the triangles are the same. So when we say two sides and the included angle, we have side, side, see how these two sides match up, and then the angle between the two sides. So this angle is actually making these two sides right here. Angle, angle, and then the two sides on either side of that angle, and that's called SAS. Side, angle, side. Not just from one triangle, but from both of them. That's how they match up. The next one we have is SSS congruence, and that stands for side, side, side. So if all three sides match up in some way, then the two triangles are considered to be congruent. And then the angles will match up also. And then we have ASA congruence. ASA is angle, side, angle. So angle, side, angle. So basically you have two angles and the included side, two angles and the included side from both triangles matching up. And then we have finally AAS congruence, and that is two angles and one side. So angle, 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 and then another side would be congruent. Now that's really the reason why this works. It's not a theorem. I mean, it's not a postulate, it's a theorem, is because if two angles match up, if the two triangles are similar, then the third one matches up automatically. It has to. So basically this one has to match up with this one over here. And if that's true, then it can also be angle, side, angle, angle, side, angle. So if this isn't given as congruent, this third angle, it doesn't matter. It's going to automatically be congruent anyway. And we can just say AAS congruence if that happens. All right, so now we're going to get on with it, and we're going to have some examples. Determine if the triangles below are congruent. If so, state the reason and write a congruent statement. That same stem is going to be for most of these. So we do have three angles matching up. Three angles matching up. So what I'm going to do, and we have two sides and two sides. So basically for this one, there's a couple things you could say. You could either say angle, side, angle, angle, side, angle. You could do ASA, but you could also do angle, angle, side. Or angle, angle, side. Either one of those would be okay to say if they're congruent. Now let's write a congruency statement. And so the way I'm going to do it is I'm going to say triangle ABC is congruent to triangle, okay, 1, 2, 3, 1, 2, 3, SRT. You'll just have to be careful that they match up. So let's check. Does BC match up with TR? BC, TR? Yes. Does AB match up to SR? AB, SR? Yes. Does AC match up to ST? AC, ST? Yes. So it is correct. And you really should check to make sure that they match up. Okay, let's try this one. This one's interesting. At first glance, it doesn't look like you have a whole lot, but you do have parallel lines here. And if these lines are parallel, these sides are parallel, then you have alternate interior angles because this would be a transversal. So these two match up, but so do these two. And then this side is shared by both of these triangles. So that matches up to itself. So then what do we have? We have angle, side, angle, angle, side, angle. So we would say A, S, A for that one. Let's write a congruency statement. So if these two triangles match up, then the third one has to also. So I'm going to say ACD. So triangle ACD is congruent to CAB. Triangle CAB. So let's check. Does AC match up with itself? AC, AC, yes. Does angle DAC match up with BCA? DAC, BCA, yes. So check complete. That one looks pretty good. All right, this one. We have a side. These two sides are the same. These two sides are the same. We have no angles given that are congruent, but we do have this third side, which is shared. And if you get a shared side, that's automatically congruent to itself. That's called the reflexive property of congruence. So therefore, we have these two triangles matching up. And so I'm going to write, oh, by the way, this is going to be side, side, side. Okay, and I'm going to write PQS, triangle PQS, congruent to triangle RQS, RQS. So I'm going to assume that that's correct. Well, let me check. Does SQ match up to itself? SQ, SQ, yes. Does PQ match up with RQ? PQ, RQ, SP, SR, SP, SR. Looks good. Everything checks out. There's more than one way to write your congruency statement. That's just one way. There's actually going to be like 6 ways that you can do it. But that's one way that you can do it, and it's correct. Okay, determine if the triangles are congruent again. So let's see. This time I have angle and angle, and I have these two sides. But you know what's interesting is this is actually a vertical pair. So I can actually label that like that. That's given to me. I can assume that these two angles are the same, even though they're not marked. So here's what I have. I have all 3 angles matching up, and I have 2 sides. So I could either do side, angle, side, or I could do angle, side, angle, or I could do angle, angle, side. So any one of those could be correct for this one. The only one I can't do is SSS because I don't have this side as being given congruent. So let's write a congruency statement. I'm going to do LMN. LMN, I'm going by angles this time. Congruent to LMN OPN. Okay, let's check a side. Is LN match up with ON? LN, ON, yes. So it looks good. That is one way to write your congruency statement. Okay, this time, kind of getting used to seeing some of this stuff like this shared side automatically. Now, it looks like a parallelogram. It looks like these two are parallel and these two are parallel, but I don't know that for sure. So I'm not given that these angles are congruent or these, so I have to just go on sides. So kind of have to go with side, side, side for this one. And then if I want to write my congruency statement, I'm going to go FEH. Yeah, congruent to FEH, and I'm going to do HGF. Okay, let's check. Does FH match up to itself? FH, FH, yes. FE, GH, F-E-G-H, yes, and F-G, or yeah, F-G-E-H. Let's see, F-G-E-H, yes. So everything matches up. Okay, here's another one. I'm just picking a bunch of, different ones, but this one doesn't have any angles in it again, but it does have a shared side. So it's looking like this one is SSS. Okay, let's write our congruency statement. So I'm going to go with WXY, congruent to triangle WZY. Okay, let's check some sides. Does WY match up with itself? Yes. WX and WZ, WX, WZ, XY, YZ, XY, YZ. Yep, so it looks good. Okay, this time I have two triangles. I have all three angles. It looks like they match up, but I don't have any sides. This, if you've noticed, all of the ways we can tell if these triangles are congruent, we have side, side, side. We have angle, side, angle. We have, what else do we have? Side, angle, side. And we have angle, angle, side. If you look, every one of those has a side in it somewhere. This one has all three. This one has this. This one has two. This one has one. Okay, all of these require a side, and if you don't have any sides given as congruent, then you really can't. So we would say not enough information. We can't really say that they're not congruent. We just can't say that they are congruent because we don't have enough information. I mean, they might be, you never know, but we just don't have enough information to classify it as one of these four. Okay, so now we're going to get some practice with those four. So this one says, decide if the triangles are congruent by SAS, SSS, ASA, or AAS. We have side, angle, and then a shared side right here. So we have side, angle, side, side, angle, side. So we're going to do SAS for that one. These are really good examples just to kind of go over a few times in the video if you need to. Okay, let's see this one. Okay, for this one, we can say that these two angles are congruent because they are a vertical pair. So we have these two sides, we have these two angles. So it looks like it is going to be angle, angle, side, angle, angle, side. So A, S. Okay, this one, we have a shared side. We have an angle here and an angle there and an angle here and an angle here. And so we have angle, side, angle, angle, side, angle. So we have A, S, A for that one. Okay, this one. Let's see, we have SAS, SSS, ASA, AAS. So we have a side, an angle, which is 90-degree angle, which is fine. And then we have a shared side. So we have side, angle, side for that one. Okay, this time we have no angles given, but we do have this third shared side. So we have side, 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 side. So this is a good example of side, side, side. Okay, this one, we have an angle 40 and angle 50. This one's 90. Well, if this one's 90 and that's 50, then this one's automatically 40. And same thing up here. This one's automatically 50. So we know that because of calculations. We can calculate that. So for this one, we do have a side. We have angle, side, angle. So we could do angle, side, angle. But we could also do angle, angle, side. So or angle, angle, side. We could do either one for that one. Okay, got a few multiple choice this time. Which of the following is a way to show that triangle WZX is congruent to triangle YZX? I would say probably here's a shared side right there. I would say side, angle, side, side, angle, side. So I would do SAS for that one. All right, this time I do have two angles and I have two sides given. So it says, which of the following is a way to show that the two triangles are the same, are congruent? So I could do side angle side, SAS. I could also do angle angle, let's see, angle angle side, but I don't have angle angle side on here. SSA is not, that's not a way. That's a trick. So if you see SSA, that is not a way to prove the two triangles are congruent. You can do AAS, but not SSA. And this one is also not a way. So whenever you see those two are immediately out. You can't do those two. But people pick them all the time. Okay, this one we have, let's see, we do have two parallel lines. We do have a transversal. So we do have this angle and this angle congruent. And because they're alternate interior, we do have these two alternate interior. And we do have a shared side right there. So we can say for this one, angle side angle for that one. So I will go with angle side angle. Okay, let's look at this one. Okay, this one, you have an angle here, you have an angle here because it's a vertical pair. These are parallel, so you do have some alternate interiors here and also here. So the two triangles are similar. All three angles are matching up, but you can't show that they're congruent because you don't have any sides that are given to you as congruent. So this one would be none of these. There is really no way to show that those two triangles are congruent. Okay, here's two triangles and we have some congruency statements. So this should be interesting. Let's use some process of elimination. Let's go with choice A. Let's look at some sides. Does AB match up with DE? AB, DE. Nope, that has one mark. That has two, doesn't it? A is out. Does AC match up with EF? That one has two marks. That one has one mark. Nope. Does CA match up with ED? CA, ED. Okay, those do have two. Okay, now let's do AB, one mark. DF, no marks. No. Let's go to BAC. Does AB match up to FE? AB, FE, yes. Does AC match up to ED? Yes. Does BC match up to FD? Yes. That one is correct. That one, it takes a while. You're going to have to just sit there and look at the congruency statements and just eliminate them, the ones that don't work because they don't match up. The sides don't match up. Okay, so this one's interesting. If triangle ABC is congruent to triangle DEF, then which of the following is not necessarily true? Well, let's go ahead and draw a couple triangles just to see what's going on, and then maybe we can kind of figure it out. And I'm just going to draw two triangles that look a lot alike. I'm going to draw the sides like this. Okay. And I'll draw the angles like this. Might as well, because we probably have to analyze some angles. Okay, ABC, DEF. Okay, not necessarily true. Does BC match up to FE? BC, FE, yes. Those are going to be congruent. So that one is true. Does measure BAC, is that measure equal to EDF? Yes, that one's true. Is ED equal to CB? ED, CB, okay, those don't match up. ED and CB are not necessarily true. So this one right now, I'm going with. Let's look at this one. CBA, FED. Nope, those two angles match up perfectly. So this one would be C for that one, not necessarily true. All right, this has been congruence between triangles. And remember to like my video and subscribe to my channel if you haven't already. We'll see you guys later. Bye.